Good afternoon, everyone. Thank you very much for joining in the class. Today we will discuss about chemical reactions and how these chemical reactions occur, okay, and the energy for the chemical reactions. Are you hearing me?
Yes, sir.
So, what is chemical reaction? I know all of you have previous idea about chemical reaction. So, what is chemical reaction? Anyone, please? What happened in a chemical reaction? I'm wondering, do you have previous idea about chemical reaction or not? Are you hearing me? Mohammad Akash?
Yes, sir.
So, what is chemical reaction?
So chemical reaction, like it's like two or more two or I mean s- two or more substance when they reacts there and converts it to a new substance. That's what chemical reaction means. I mean দুইটা হচ্ছে গিয়ে ডিফারেন্ট সাবস্টেন্স মিলে যখন নতুন একটা ডিফারেন্ট একটা সাবস্টেন্স ক্রিয়েট করে তখন হচ্ছে গিয়ে এটা chemical reaction. That's how.
Okay, so in chemical reaction, one or more substance
Yes.
that interact together, okay,
Yes, sir.
and form a new product. Is it clear?
Yes.
So here you can see the example of carbon dioxide and oxygen combine together to form carbon dioxide, right?
Yes, sir.
So here, like, which are the reactant and which are the product?
Product is carbon dioxide.
And reactant?
It's carbon and oxygen.
Okay, thank you. Okay, so how can we know that a chemical reaction happened or not? So when a chemical reaction occurs in a test tube or a beaker, there may have change of color in the beaker or test tube. A precipitation may form, and the beaker or test tube may become like hot or cool. Okay, And if you smell from there, you can get a smell. Okay, is it clear?
Yes, sir.
Okay, so in this reaction, which are the reactant and which are the products?
So methane and oxygen are the reactants, and carbon dioxide and water are the products.
Okay, thank you. So the number of the oxygen and number of the carbon and hydrogen are same in both reactant and product, or is changed?
Same, sir.
Okay, so in chemical reaction, basically some chemical rearrangements occur, right? And the number of the atoms are same. Is it clear?
Yes, sir.
So
Okay, so we all know in chemical reaction that occur in like various different steps, and also like the compound that participate in the chemical reaction that have state. So what does state means? State means their condition, okay? Whether they are solid, whether they are liquid, or they are gas, okay? Is it clear? And if they are dissolved in water, then we called aqueous. And in chemical reaction, we have to mention their state, okay? So for mentioning solid state, what symbol we use?
S.
S. And for liquid?
L.
L.
Okay, great. And for gas?
G.
G.
And dissolved in water?
AQ.
AQ.
AQ. Okay. So it's simple, right?
Yes, sir.
Okay, so in that reaction, can anyone tell me the state of sulfur?
Solids.
So solid.
Okay, so sulfur react with gaseous oxygen to form sulfur dioxide, right? So what's the state of sulfur dioxide?
Gas.
Gas. Okay, thank you very much. So chemical reaction, we can broadly divide it into two types: elementary reaction and composite reaction. Okay. So what is an elementary reaction? Any idea?
So single step reaction.
Okay, great. And composite reaction?
So something that
That
takes more than one step.
Okay. What is the molecularity then? Molecularity of an elementary reaction?
the number of reactant molecules involved in the reaction.
Yes. So if just one molecule attend in the reaction, then
It's unimolecular.
okay. If two,
Bimolecular.
and if three,
Term molecular.
okay. So is it clear to all?
Yes, sir.
Yes, sir.
Okay. So here you can see the examples. So can anyone discuss about this one, unimolecular reaction? What happened here?
So cyclopropene, the atoms of cyclopropene rearrange themselves to form propene.
Yes. So here number of reactant and products are
Same.
okay. And can anyone discuss about this one? Bimolecular reaction. What happened here?
So the two reactant molecules reacted with each other, and they substituted themselves to form the product.
Okay, so number of reactant here. Number of
One.
reactant.
Plus 2.
Two reactants.
Two reactant here, right?
Two reactants.
Ethyl acetate and water. Okay, so what happened in thermomolecular reaction?
So two different reactions took place.
Not two different reactions, single step reaction. Okay, here. So here is two different example. Okay.
Oh, sorry. Okay.
So here more than two compound combines. Okay, like here you can see that three compounds, right? Three compounds combine together to form a product. Is it clear?
Yes, sir.
Yes,
So
sir.
here you can see two nitrogen monoxide combined. So here like A and B is same. Okay, C is different. Is it clear?
Yes, sir.
So what is thermomolecular reaction?
Three
Three
molecules
different
reacting to form a product.
Okay, is it clear to all?
Clear, sir.
Okay, so why the high molecularity reactions are rare? So we know that in reaction, each of the compounds interact together, right?
Yes, sir.
And then rearrangements in their atom happened, and then they form a final product, right? So when the molecularity increased, like more than 3, then their chances of collision decreased. Okay, is it clear?
Yes, sir.
So when the chances of collision decreased, then the chances of this reaction to happen also decreased, right? So that's why high molecularity reaction is rare.
স্যার একটু কনফিউজিং লাগতেছে
Okay, sure. Where?
স্যার মানে তিনটা হয় না কারণ স্যার মানে রিঅ্যাক্ট্যান্ট কমে যায়
Okay, I'm clarifying it. Are you seeing the screen?
ইয়েস স্যার
So here you can see these compounds need to interact together, okay, to form a product. So when the number of reactant increased, the chances of this collision decreased, okay. Say if here there is like 5 reactant, so then each of this reactant must have to combine together to form a product. So the chances of collision decreased, okay.
স্যার কেন স্যার কলিউশনের চান্স কমে যায়
Because their number is increasing, right? So like putting everything together is decreasing. Is it clear?
নো স্যার
No, okay. So like if there is any compound like here, here and here, okay, like so consider this like here a compound, here a compound and here a compound, and when this combine together they form a reaction. So their chances of like collision with each other decreased. Is it clear?
ক্লিয়ার স্যার
And when the chances of collision decrease, so the chances of reaction to happen also decrease. Is it clear to all?
Yes, sir.
So can anyone explain me now why high molecularity reaction is rare?
So when there are more reactants, there is less chance of them colliding. This is why high molecularity is rare.
Okay, thank you very much. Okay, so now we'll talk about another kinds of reaction, that is composite reaction. So we know that composite reaction, there are more than one elementary step. Okay, is it clear?
Yes, sir.
Okay, so composite reaction we can divide into three different types: side or parallel reaction, reversible or opposing reaction, and consecutive reaction. Okay, so reversible reaction, I know everybody of us know, right? What is reversible reaction?
Yes, sir.
Yes, sir. I know.
Can anyone tell me what is reversible reaction?
So in
Sorry.
reversible reaction, we can have the two reactant to create a product, and we can also from that product we can find the reactants.
Okay, that means this reaction can go to the forward and reverse direction, right?
Yes, sir.
Okay, so can anyone talk about this reaction, this reversible reaction? Any one of you? It's easy, right? Not difficult.
Sir, hydrogen and iodine collides and and products into hydrogen iodide, and the same and the vice versa happens too.
Okay, so when they collide with each other, what is formed?
Hydrogen iodide. So
Okay, and hydrogen iodide can also break down into
hydrogen
hydrogen
and
and iodine.
iodine.
Okay. Okay, then what happens in side or parallel reaction? From the figure, can anyone tell me what happened here?
So one reactant can produce the more than one products.
Okay, so one reactant can go either this pathway or this pathway or this pathway. Is it clear?
Yes, sir.
And what happened in consecutive reaction? Here. Here is the reactant and here is the final product.
So an intermediate product is formed from which we get the final product.
Yes, thank you very much. So this is our intermediate product, right? B. Is it clear?
Yes,
This one
sir.
is the intermediate product. Okay, so here you can see the example. The first one is the side or parallel reaction. Okay. Can anyone describe that what happened here actually?
So bromobenzene reacted with bromine to form two products. Either can form two products. Either O dibromobenzene plus HBr or P dibromobenzene plus HBr.
So what does this O and P means?
Sir,
P
the
P
arrangement
stands.
of bromine.
Okay, so this is position, right? Position of bromine,
Yes,
isn't
sir.
it? So what this position called?
P refers to para, but I forgot what O refers to.
Yes, sir.
Okay,
Same.
O refers to ortho position. Is it clear?
Yes, sir.
And P refers to para position. So when bromine joined here, what happened actually? Bromine replaced one hydrogen, right?
Yes, sir.
And
So
then that
one,
hydrogen went on to react with the other bromine atom and formed hydrogen bromide.
okay, great. Thank you very much. Is it clear to all?
Yes, sir.
Clear, sir.
Okay, then what happened in the consecutive reaction?
So dimethyl ether reacted and so made some intermediate products like methane and formaldehyde, and those two reacted into hydrogen and carbon monoxide.
Okay, great. Is it clear to all? So methane and formaldehyde is the intermediate step, right?
Yes, sir.
Okay, so do you have
স্যার
any
আরো
idea?
কিছু এখানে স্যার থাকবে না স্যার লাস্টে? হাইড্রোজেন আর কার্বন মনোক্সাইডের সাথে তো আরো কিছু থাকবে মনে হয়।
Like,
মানে এখান থেকে যদি একটা কার্বন যায়, স্যার বাকিগুলো কই স্যার? বাকি যে রিঅ্যাকটেন্ট গুলো ছিল?
ও এখানে আসলে সমতাকরণ করা হয় না আর কি।
হ্যাঁ হ্যাঁ
ব্যালেন্স
স্যার।
করা নাই।
আচ্ছা। Okay, can anyone tell me what is the functional group of ether?
CH3.
স্যার CH নাকি?
CH3 is methane, right? Methyl group. Is it clear?
Yes sir.
So here is also a methane group, right? So,
Yes sir.
so these are not ether. Okay, so what is the functional group of ether? So this like methane we can also write R. R here also R. Okay. And this R may be like methane, ethane, propane, anything. Is it clear?
Yes, sir.
So ether group is ROR. Is it clear?
Clear sir.
Okay, and what is the aldehyde group here?
CHO.
Okay, CHO. Thank you very much. Any question from here? Okay, not okay. So in a chemical reaction, there is like certain steps or procedure how this reaction happen, and this we called reaction mechanism. Okay. So in chemical reaction, a set of elementary reaction occur, right? For example, here you can see a set of chemical reaction, and here this is the overall reaction. Okay. And these are the mechanism of this reaction. Is it clear? So if we like break this equation step by step, then we get the mechanism of this reaction. Okay. So this reaction actually happen in 3 different steps. Is it clear? Are you hearing me? Are you hearing me or not?
So can you please explain again?
Okay, so if we discuss reaction mechanism, then we have to know that the steps how this reaction occurs. Okay, so reaction mechanism actually we are try to understand the steps by steps in which the reaction occurs. Okay, so in every step, you know, you can see the elementary reaction, right?
Yes, sir.
And when this elementary reaction are combined, then we can get the mechanism of this reaction. Okay, for example, this reaction you can see just a single step, but to happen this reaction, actually 3 different steps occur. Okay, so these 3 steps is the mechanism of this reaction. Okay, is it clear?
Yes, sir.
Okay, so what is the name of this compound?
So nitrous pentoxide.
Okay, nitrous pentoxide. Why nitrous?
So there are two nitrogens. So
Okay. Is there another name of this compound?
I don't clearly remember, sir.
Okay. Any one of you? Dinitrogen pentoxide. So why di? There is 2 nitrogen, right?
Yes, sir.
Okay, so what happened in the first step?
Sorry, dinitrous pentoxide broke into nitrous dioxide and nitrous trioxide.
Okay, nitrogen dioxide and nitrogen trioxide.
Dioxide.
Okay, in the second step,
So nitrogen dioxide and nitrogen trioxide reacted and created nitrous monoxide, oxygen, and nitrogen dioxide.
okay, nitrogen monoxide, oxygen, and nitrogen dioxide.
Yes, sir.
Okay, so in the third step, what may happen?
Nitrogen trioxide and nitrogen monoxide reacted, and 2 moles of nitrogen dioxide was created.
Okay, so if we combine this reaction together, then we get this. Is it clear?
Yes, sir.
So this is the mechanism of this reaction. Okay, and the procedure of dinitrogen pentoxide breakdown, we called it decomposition, right? Decomposition means dividation. Is it clear?
Yes, sir.
Breaking down. Okay, so from this step we can see that this reaction actually is a composite reaction, right? Because it happens through multiple steps, isn't it?
Yes, sir.
Okay, so here you can see some of the steps are faster and some of the steps are just one step is slower, right? This one.
Yes, sir.
So this step is the rate determining step. Okay. So why this one is the rate determining step?
So is it because it produces more products, or
So if we wish to get from here to here, we need to pass through these steps, right? Okay. So if these steps happen faster, then also we can get this. Is it clear? If this step is slower, we can get it at a faster rate. This. Is it clear?
yes, sir?
So that's why this is the rate determining step. Okay, so in a chemical reaction, we know bonds break down and new bonds are formed, right? And
Yes, sir.
in the bond breakdown and bond creation process, we know energy either released or energy is absorbed, isn't it?
Yes, sir.
Okay, so what is a potential energy diagram? What is the potential energy diagram?
So in the diagram, we see that how energy changes during a reaction.
Okay, so potential energy diagram represents potential energy change during a chemical reaction. Okay, is it clear?
Yes, sir.
Okay, so here we can see two different terms, exothermic reaction and endothermic reaction. So what happened in endothermic reaction?
Sir, in endothermic reaction, the reactants have less potential energy than the products.
Okay. And what happened in the exothermic reaction then?
In the exothermic reaction, the reactants have more potential energy than the products.
Okay, so in endothermic reaction, energy produced or absorbed?
Absorbed,
Sir,
since reactants have
ab-
less potential energy than the products has to get that energy from somewhere else, so it is absorbed from the surroundings for endothermic reactions.
And for exothermic reaction?
Since reactants have excess energy, it needs to be released, so the energy is released to the surroundings.
Okay, is it clear to all?
yes, sir.
Yes, sir.
Any confusion here?
No, sir.
Okay. So then what is the activation energy?
When molecules or atoms of two reactants collide, the collision has to reach a certain level of energy before any reaction can occur, and we call that the activation energy, because if the collision has less energy than the activation energy, then no reaction will occur.
Okay. So in a chemical reaction, before it starts, the bond between the reactant need to be break down, right? For example, here you can see that there is bond between A and B, right? isn't it? Here, there is bond between A and B, right? And the final product is A and C. So this bond, first we need to break down, okay? So to break down this bond, we need energy. Is it clear?
Clear, sir.
Okay. So through the activation energy, these bonds are break down, okay? And when this bond break down, they form a complex that we call active complex, okay? So here in the active complex, you can see there is no bond, okay? These compounds are individually separated. Is it clear?
Yes, sir.
And then from here, the bond creation started, okay? So in the product, we can see A and C created bond together, right? So in the bond creation process, we know that energy is produced, okay? Energy is released. Is it clear?
Yes, sir.
Okay, and if a reaction is exothermic or endothermic, we need to determine based of the energy of the reactant and product, okay? Is it clear?
Yes, sir.
So in this reaction, you can see the energy of the product is less or higher than the reactant.
Sir, in the exothermic, the energy of the products is less than the reactants.
In exothermic, products are
The energy of the products potential energy of the products are less than the reactants.
okay. So what will happen when this product is formed? Temperature will be absorbed or released.
So
Okay, we are going back here. Here you can see the gap, right?
yes, sir.
The energy gap.
Yes, sir.
Okay, so what will happen here in the
Sir,
exothermic reaction?
so exothermic reaction, energy is released.
Okay,
So that means temperature will release too.
okay, and here
Energy is absorbed, so temperature will rise.
energy will absorbed. So the surrounding temperature will be decreased, right? Isn't it? From the reaction medium, the product will take temperature, isn't it?
Yes, sir.
Is it clear to all? Any question from here?
No, sir.
So can anyone explain about the activation energy and activated complex?
So the activation energy is the minimum energy required for the reactant to collide with each other and start the reaction.
Okay, and the activated complex? What is the activated complex? Anyone, please? Did you understand it or not? If not, then I can explain it again. No problem at all.
Sir, in activated complex, when the reactants react, the energy reaches to peak.
Can you explain it again?
Sir, while the reactants react, the reactant molecule becomes unstable, and the growth of energy goes to the peak, and this
Okay, so
forms the
what
active.
happened between the bonds here in the activated complex?
Sir, the bonds first broke and formed another bond in the intermediate step, and in the final step they formed a new bond.
Okay, so in the activated complex, is there any bond here or not?
No, sir, there is no bond.
Okay, thank you very much. And the energy of the activated complex is more or less than the product?
Sir, it's more than the product.
And if we compare the energy of the activated complex with the reactant, is it less or more?
It's more, sir.
Okay. So in both the reaction, whether exothermic or endothermic, we know activated complex form, and the energy of the activated complex is more than the reactants or product. Am I right?
Yes, sir.
Okay, so to form the activated complex, we need energy, isn't it?
Yes, sir.
From the surroundings. Okay, is it clear to all?
Yes, sir.
Okay, so can anyone explain me now the activated complex other than those who have explained? A new person, please. If you are comfortable in Bengali, then it's fine, no problem at all. Anyone, please? Sadia Alam, are you hearing me? Samia Haq,
Yes, sir. Sorry,
can
I
you?
couldn't hear you, sir. My internet connection has been really bad.
Okay, so did you understand this activated complex or not?
Yes, sir. Bits of it, parts of it got disconnected.
Okay, so how do you understand? Could you please tell me?
Sir, activated complex.
Yes, activated complex.
Sir, activated complex are the parts of the reactant molecules that are unstable and
Hmm.
decompose to form the products.
Okay, so how's the energy level of the activated complex?
So the energy level of the activated complex is, sir, energy level of the activated complex is usually higher than the reactants and the products.
Okay. So is it same for the exothermic and endothermic reaction or not?
The potential energy for the activated complex.
Yes.
Sir, I did not get that part. Actually, it got disconnected.
Okay, so here you can see from the graph, the
Yes, sir.
potential energy of the activated complex is higher than the reactant or product in both the cases, right? Whether
Yes,
the
sir.
reaction is exothermic or endothermic. Is it clear?
Yes, sir. That part is clear.
Okay, thank you very much.
Yes, sir.
Okay, so do you have any idea what is reaction rate or rate of a reaction?
Yes, sir. The time taken for the reaction to be completed and form the products.
Okay, so what happen in a chemical reaction?
The reactants collide to form new products.
Okay, and if we consider the concentration of the reactant,
The concentration of the reactant decreases over time,
and the concentration of the product,
increases.
okay, is it clear to all?
Yes, sir.
Okay, so here which one is the reactant and which one is the product?
So A is the reactant and B is the product,
How you got it?
because A disappears and B appears.
Okay. And what is the positive signs here indicate? What is the positive sign indicate here?
So increase in the reactant or the change.
Okay, increase in concentration, right?
Yes, sir.
Okay, so rate of the reaction means
Decrease in the concentration of the reactant or increase in the concentration of the product per unit time.
okay. So the change happen with time, isn't it?
Yes, sir.
Okay, so d concentration by dt. Okay, so change of the reactant with time, and here change of the product with time. Is it clear?
Yes, sir.
Is it clear to all?
Yes, sir.
Can another person explain what is reaction rate? A new person? It's easy, right? It's not difficult. So I think all of you should answer this question. Don't feel shy or hesitate, okay? You can also answer in Bengali as well, no problem for mind. Anyone, please? New person?
Sir, the rate of reaction means how in what rate the reactant will decrease or the product will increase per unit time.
Okay, so here How can we express it, the rate?
So here we can see that the A is the reactant and B is the product. So the d of A by dt, minus d of A dt is like the disappearance or the reduction of the rate which is reducting, like disappearing, and the plus dv plus dv by dt is the increasing of the product, increasing rate of the product.
Okay, so here the positive signs indicate that the number of the product is increasing, right?
Yes, sir.
So the positive sign means increase, isn't it? And
Yes,
the
sir.
negative sign indicate decrease.
Decreasing.
Okay, is it clear to all? Any confusion from here? Anyone? Any question?
No, sir.
Okay, so here is a math problem. Can anyone solve this problem now? Take a pen and paper and solve this math. It's simple, right? Not difficult. Easy math. You can see the time here and the concentration here. Okay. So you need to calculate change of the concentration with change of time. Okay. Then we can get the reaction rate. Is it clear? Did you get the answer? Please mute your volume if you are not talking. Okay. Have you completed? Any one of you? Asad, are you hearing me?
Yes, sir.
Have you completed the math?
Sir, 0.0013 আসে।
Okay. How you calculated?
Sir, before reaction, after reaction, concentration সাবট্রাক্ট করেছি আর টাইম সাবট্রাক্ট করে ডিভাইড করেছি।
আচ্ছা, বিফোর রিয়াকশন আফটার রিয়াকশন কত আসছিল?
0.0013।
হিয়ার
না মানে ওটা 0.08 স্যার, ওই যে 0.2
Okay.
minus 0.12।
টাইম ইজ অলসো সেম, রাইট?
হ্যাঁ স্যার।
Okay, so if you divide this one by this one, what is the value?
স্যার আমার স্যার 0.00133333 এরকম আসছে স্যার।
0.001.
হ্যাঁ 001 তারপর 333।
আচ্ছা, তো সেটাকে যদি আমরা 1000 দিয়ে গুণ করে দিই তাহলে কত আসে?
1.3।
1.33. ওকে, এন্ড আমরা যেহেতু 1000 দিয়ে গুণ করছি সেই কারণে 10 to the power -3 লিখতে পারি, রাইট?
হ্যাঁ স্যার।
ওকে, ইজ ইট ক্লিয়ার টু অল?
Yes, sir.
Yes, sir.
Okay, so how can we determine the rate of a reaction? If we know the concentration of the reactant or product with change of time, right? Isn't it?
Yes, sir.
Okay, and also if there is any diagram of the change of the reaction product and the reactant with the time, then we can also figure out the reaction rate, right?
Yes, sir.
Okay, so any question from here? No? Okay. Okay, I am closing this session for today. So those who joined, can you please type your ID and name for the attendance? Some of you already typed. Mahabubul Arifin Khan, are you hearing me? So did you get your answer? Is there any problem from your end? Okay, thank you very much for joining in the class. I am closing this session for today. We'll see you in the next class. Stay safe. Bye.
Assalamu alaikum, sir.
Thank you, sir.
Assalamu alaikum.